couple of hints on this that I'm asking you to work on. We're going to come and look at the homework in just a couple of minutes. But as you're working on this, I want you to be asking yourself some questions. What kind of data you're asking, that's really the first question you should ask yourself, is what kind of data, qualitative versus quantitative. And so that's something that you want to be thinking about. When I have qualitative data, that automatically puts me in chi-squared situations, doesn't it? It could be proportions, but usually that's a different scenario. When I'm talking about quantitative, you want to ask yourself how many quantitative variables I have, and then how many samples I have. And that should kind of help us and guide us as to what type of a situation we have. One of the things that I do want to write down is in the first column, you're writing the name of the test. When you have the test decided, then you have to tell me the test statistic and the degree of freedom. So let's just kind of refresh our memory real quick. When I have a chi-squared, what's the test statistic? Chi-squared. Okay, and what's the degree of freedom? Rows minus 1 times columns minus 1, unless it's goodness of fit, and then it would be n minus 1, where n is the categories. Wouldn't you agree? So if I just write categories minus 1, would that be okay? All right. What if I decide that I'm dealing with proportions? Whether it's 1 sample or 2 sample, what's the test statistic that goes with any kind of proportions? A z. And what kind of degree of freedom do I have? There's no such thing as a degree of freedom with a z-score. Okay? So n/a, please don't write 0. Okay? Make sure you're telling me that nothing doesn't exist. Degrees of freedom don't exist with the normal curve, only with the t. When I talk about means, whether it's 1 sample or 2 sample, what kind of a test statistic do I have? A t. And what's my degree of freedom? n minus 1, where n is the sample size, right? The difference is if I have 2 samples, then remember I told you to use the calculator, right? So you can just write calculator in there. That'd be okay. The last one is if I'm talking about linear regression, what kind of a test statistic do I have? It's t still, but the degree of freedom would be n minus 2. So that's just kind of a summary a little bit to kind of help us. Once you've decided what test it is, it should be pretty smooth sailing to get to the last part. Okay? So I'm going to pause for a minute, let you guys continue to work on that. I would like to go over the homework as well, and then we will summarize this chart together. Okay? So I'm going to give you some time to work on that. What I'd like for you to do, we're going to come back to the matching situation in a minute, and I actually have a little game that we're going to play in a few minutes too, where you can earn extra credit on next week's test. But anyway, we'll come back to that in a couple of minutes. What I'd like to look at is your homework. I did put the even answers up here, so if you would kindly look it over your even answers. A lot of people, I did grade number 30, by the way, as your extra credit problem, and quite a few people did get a 6 out of 5, which is great. But I would like to go over number 30 since it was the only confidence interval that you had to do. Problems 11 and 13, the answers were in the back of the book. And so we can go over those if you'd like to. Some things on the hypothesis test that I want to point out would be that to make sure that you are using the variables in, the pen type won't let me change, awesome. But you're using these variable words in the context of the problem, okay? So when it asks you to write the equation, make sure you're doing that. We're going to look at a problem in a little bit from a computer printout that's a little bit different than what you'll see from the homework. I'd like to do one of 11 through 14. I don't care which one. So you guys tell me which one looks like the one you'd like to go over. I heard 12, I heard 14. We're going to do 30 for sure. 11 through 14. 12? Okay, let's do 12. Okay? So we'll do 12. I want to make sure we're looking at a hypothesis test, and then we'll do 30. Okay? Fair enough? So let's start with 12. I'm going to give you, I'm going to write up here on problem 12 what the computer printout was to make sure that we fully understand what it is that we were given. So here is the computer printout that's given to you. I want to point out some information that's useful to us, and it won't let me do highlighter. I love this smartboard. These numbers and these numbers are the only useful pieces of information that you really need. Okay? Let's remind ourselves what they are. What is 0.35707? That's the no, it's B naught. It's the y-intercept. It's why it's next to the word intercept. Okay? So it's going to be B naught, which is your y-intercept. Okay? Down here, 0.14264 is the B1, so that would be the slope. Okay? That's the number that you use in your confidence interval. That's the number that you use to find your test statistic. That is an important piece of information. This is your standard error of B1, which is also used in your confidence interval, also used in your test statistic. The t ratio, that is just your t. I'm going to tell you that on your test, you're not going to be given that. On your test, you're only given what I've circled in blue. So you're going to have to find these two numbers over here by yourself. Can you do that? How do I find 3.512 if I wasn't given it? How do I find it? Do you remember what the formula is? It's going to be your slope minus 0 divided by the standard error of the slope. So it's this number minus 0 divided by that number. Right? So try on your calculator, see if it's not true. Is 0.14264 divided by 0406, is that 3.512? Check it for me. It should be, but check it on your own with the calculator. Is it 3.512? It is. It should be, right? Okay. So you don't really have to be given the right two columns. Would you agree? They're not necessary because you can find them. That happens on your test. Okay, so just make sure you know that. How would I find the p-value if it wasn't given to me? I have the test statistic now. Do you remember how we find the p-value? Remember, because in a linear regression, we are talking about a two-tailed test. So I have 3.512. So we're going to do 2 TCDF. And we have one of the tails, the left bound and the right bound of one of the tails, but I'm missing the degree of freedom. I didn't write it down, but it was actually provided to us. So I'm just going to look back at my printout. It says my degree of freedom was 20. Okay, so that's usually part of the computer printout, and it was here, so that's what we'll put in. So tell me, plug that in, make sure that you get 0.002. Hopefully you do. If you're given a problem like this, it will be part of the printout. It might give you the sample size, then you would just subtract 2. That would be another situation that could happen. Did you get 0.002 when you multiplied it by 2, hopefully? Okay, so these right-hand two numbers that I have in red here can be found, okay, with the information provided. But there's your printout. Going back to problem 12, in part A, it asks you to state in context what the regression says. So let's go back. So in context, what the regression says just is using your variables. The context of this situation is, if you use cannabis, are you more likely to use cocaine? It's a kind of like, is there a progression to go to harder drugs? I guess that's kind of what is there a relationship between those two things? And so that is in context. Notice where these numbers came from. 0.357 and 0.153 should have come from the printout, and they did. Okay, so that's where they came from. Question B says the hypotheses in words that describe how they use, about the slope, how marijuana is associated with other drugs. And so basically there is no relationship between cannabis and cocaine usage, or there is a relationship between cannabis and cocaine usage. Okay? And I've written it in context and in, what did you say? Symbols. That's the way to say it. Okay? We're given that the test statistic, was it negative 9.25? Did I write down the wrong number? Looks like I must have, because that's not the test statistic. Let me see if I wrote down the wrong number in the back of the book. Looks like I did. Oh yeah, totally did. So these are not the right values. Would you agree there? Okay. It should have been 0.002 and 3.5 something? 3.51. So that's my fault. I just read them wrong on the back of the book. That p-value is small, because I'm not going to compare it to, it's less, show linkage, it's less than 0.05. Therefore, I will reject the null hypothesis, which means that we have evidence there is a relationship between cannabis and cocaine usage. Okay? Part D talks about R squared. If you look at the computer printout, I didn't include it, but it was actually given to you. It says that R squared was 38.1%. It is the square of the correlation. So if you remember the R that comes up on your calculator, if you actually literally just square it, you'll get that number. But what does it measure? It measures the variation. Oh, went the wrong way. It measures the variation. Remember we said I wish I could highlight, but we're going to take, maybe if I use red, show it better. We're going to take this percent and this Y variable and this X variable, and it's the same sentence every time. It's a percent of variation in Y that is explained by X. So you just have to look and figure out what those variables are. Okay? And that's what they asked you to do in D. Based on everything, based on rejecting my null, saying that I have evidence of a relationship, we can say that we have evidence that they are in fact associated, but they wrote in the back, just because they're associated, one does not cause the other to happen. Remember, correlation does not imply causation, so we have to be careful with that. Okay? Is that clear on 12? Okay, let's look at 30. In question 30, you are talking about, just so I have the right frame of reference here, SAT scores from 28. If you look at question 28, remember the formula that you need for a confidence interval is this. So we have to pick out the key pieces of information. It had you refer back to question 28, which was a computer printout. You want to make sure that you are looking for, oh, hang on, I'm going the wrong way here. There we go. We're looking for the slope, and we're looking for the standard error of the slope. So you're looking for these two numbers, the first two numbers in the second row of your computer printout. So in question 28, it looks to me like the slope numbers. Am I looking at the right thing? That doesn't look like the right thing. Oh, I'm looking at the wrong thing. Okay, good. So 0.675 looked to me like it was the slope. We'll come back to the degree of freedom. And then in the computer printout, it looks to me like the standard error was 0.0568. Strictly just taking those numbers from the printout. How do I find the degree of freedom? What we're going to use inverse T, the degree of freedom should be listed on the computer printout. It says here that it was 160. So we're looking at the degree of freedom here to be 160. But you're right. To find T star, we are going to do inverse T. Does it tell you what percent of the a 90% confidence interval. We are so used to doing 95. So how much is in one tail? 0.05, which means that we're doing inverse t of what? 0.95, good. And then our degree of freedom of 160. And I don't know what number you get there. 1.65? Okay. And so then you would just go ahead and hopefully if you add and you subtract, you will in fact get the answer that I have over there, 0.581 and 0.769. Okay? Remember that this is not something the calculator will automatically do for you. Okay? All right. Any other questions from homework? All right then, let's go ahead and look at this bad boy. Let's fill in our chart. Let's see how well we do, maybe. If I can get there. There we go. We're going to look at our scenarios and decide to fill them in one by one and see how well we do. Okay? So you all have this in front of you. I'm going to ask you to recreate this exact type of chart. The scenarios at the bottom will be different and in different orders, so you don't want to just memorize the chart because that won't help you. But the process is going to be similar. So let's look at the first example. Doctors offer small candies to 60 teenagers, recording the number they consume, and then test blood sugar levels for each. So when we look at this particular scenario, am I talking about qualitative data or quantitative data? Is it measurable or not? Blood sugar level is definitely measurable, wouldn't you say? And the number of candies they consume is also measurable. So I have two quantitative variables. Would you agree? Two quantitative variables means it's linear regression, period. So it's number 9. So that's going to be your hint. Two measurable quantitative variables. And you're trying to see if they are related. That's what we've been doing. Are the two measurable variables related to one another? That is your cue for linear regression. Okay? So when I have regression, what's my test statistic? T. My degree of freedom is sample size minus 2. Sample size was 60. My degree of freedom should be 58. Okay? Only saw a handful of us that had that one right. Okay? If you did, awesome sauce. But make sure that you know it's it's 58. Okay? All right, let's look at B. Which takes less time to travel to work, car or train? Time is the variable I see here. Is that qualitative or quantitative? Quantitative, again, it's a measurable thing. Is that the only variable I'm measuring? Yes. Time is what I'm measuring. What am I doing, though? Comparing those times. I have one sample of 45 businessmen, but I'm measuring 2 different times for those 45. I'm going to take those 45 people and put them on a train, takes them how long they get to work. Those same people, I'm going to put them in a car and measure how long they get to work. Does that clarify what answer it should be? What answer is it? It's matched pairs. It's matched by person. You're looking at the difference between their times. It's the same businessman riding the train and the same businessman riding in the car. So it's matched by person. So that's a matched pairs situation. So that's going to be 4. When we have matched pairs, what's the test statistic? T again. When I have matched pairs, the degree of freedom is going to be sample size minus 1. So what was our degree of freedom? 44. Good so far. Okay? Let's look at the next one. Orthodontist wonders if soda maybe a factor in cement. My daughter gets braces next month. I need a second job. They're expensive, y'all. Oh my gosh. Anyway, okay. Quantitative or qualitative variable here? Say it louder, Maria. It is quantitative. The force is what's being measured. Shoot, it says the word measured in the problem, doesn't it? So if it says the word measured, that should be a clue, right? That we're talking about quantitative. That rules out chi-squared automatically, wouldn't you agree? We're measuring something. So we're really dealing with t's. We're dealing with means somehow. I've got 40 people who don't drink soda and 40 people that do. Are those samples matched in any way? Aren't they independent samples? So does that answer your question? So this should be 5. Would you agree with that? Okay. Test statistic is a T again. What about degree of freedom? This is the one where the calculator is the best option, okay? Because there's so many schools of thought in the past when we didn't have this technology. Some people said for degree of freedom to use the largest sample size minus 1. Some people say to add them together and subtract 2. What's the most accurate, is the formula the calculator uses. So in this case, I literally want you to write, use the calculator. Okay? That says calc, by the way. Okay? That's the only case where I want you to do that. All right, let's keep going. We're looking at D now. We had complaining of allergies. I'm telling you what, allergies is my life. My daughter's allergic to everything. Both my sons and me get allergy shots. We're going this afternoon. I think I should own stock in Zyrtec and Allegra. I'd be wealthy. All right? Anyway, 40 people complain of allergies taking an antihistamine. They report their discomfort subsided in an average of 18 minutes. Shoot, they said the word average. That means mu, that means x bar, that means I'm dealing with t's, so that should clear me. I'm talking about means, right? I'm measuring something. Time is measurable, quantitative data, okay? Keywords, average, time. How many samples do I have here? 1. It's 1 sample of 40, right? So what's my answer for D? Mean 1 sample. I'm dealing with T's. My sample consisted of 40 people. So what's my degree of freedom? 39. All right, Maddie, let's read E. Okay? And E, Maddie, tell me what kind of data we're talking about. Qualitative or quantitative for E? Yeah, it's qualitative. It's qualitative. Because I got name of hospital. I've got 4 different hospitals. And then I also have the reason for which they're in the hospital. That's not measurable. That's a qualitative variable, right? That's something that's a category. Shoot, it even says the word category is in the problem, right? That's a clue. Use that. So if we're talking about qualitative data, which set of tests are we talking about? Chi-squared. But I have 3 of them to choose from. Well, according to AP, as long as you write chi-squared, you're good. Psh. Anyway, I've got goodness of fit, homogeneity, and independence. Which one of those am I talking about here? We're trying to figure out whether or not they are similar in all 4 major hospitals. Are they homogeneous or not? So it's homogeneity. That would be 7. We are talking about chi-squared. What's your degree of freedom, though? 9. Do you know where 9 came from? You have 4 major hospitals. That's one of the rows. How many categories do you have for being in the hospital? Accident, illegal activity, illness, or other. You got 4. 3 times 3 is 9. So 9 is your degree of freedom. Count again. Accident, illegal activity, illness, other. Yeah. Okay. All right. What do you think about F, Karen? What kind of data are we talking about with F? Qualitative or quantitative? I see percents, I get excited. It's, say it again. Say it again. There you go. It's qualitative, okay, because we're talking about categories. First category is less than 15 years of age. The next category is between 15 and 65. Then we have over 65. I have 3 categories. Okay? Oh, did I skip? I'm sorry. I went right to G, Karen. Poor Karen. Let's go back to F. Sorry about that. I skipped right to G. My bad. All right, back to F. I still have percentages. Okay? 40% of older drivers speed on highways. That's what the status quo is. That's what the belief is. That's what the null hypothesis states. But then I did a survey, and my survey said 49 out of 88. Am I dealing with proportions or means? Proportions. So that's going to be a Z situation. Wouldn't you agree? All right. How many samples do I have with F? How many do I have? I have 1, because I had a claim that I'm comparing my 1 sample from. So the 49 out of 88 is the sample. That 40% is going to be your proportion, your claim. P equals 0.4 is your null hypothesis. Right? The 40% is what goes in that null and alternative. But the 49 out of 88 is your p hat. Okay, so F would be 1 proportion. It is Z's. What's true about the degree of freedom? It doesn't exist. Okay? Not applicable. All right, let's look at G. That's the one I skipped to. Sorry, Karen. Okay. I've got 3 categories. I have a historical population with percentages that I'm comparing it to, and I have my sample from Canberra. Am I saying that right? I've got 210 residents. Say it again. Was it Canberra? Canberra? I don't even know. Whatever, there, okay? So are they unusual in any way? We're comparing them to that historical, so what is that? Goodness of fit. That's 6. It is a chi-squared goodness of fit test. So G would be 6. What's the degree of freedom? What's the degree of freedom? No. What's the degree of freedom? It's the number of categories minus 1. How many categories do I have? 3 categories. So the degree of freedom should be 2. 3 minus 1 is 2. The last question is the one that could possibly have multiple answers, but I think that most of us, make sure you're filling in the blanks. Make sure that you're, most of us would probably pick, I would hope, the first choice. So if you look at H, what do you notice? You have percents, and I have how many groups? 2. So we're looking for the difference between men and women about whether or not they were adopted, right? So isn't that two independent samples? Difference of proportions, wouldn't you agree? So to me, that is 2. It's z's with no degree of freedom. The other possibility here is you could, if you wanted to, take those percentages and create counts. And then you could do a chi-squared test. Okay? So that would be the other option. But the data is not presented that way. They're not presented as counts, but you could translate them into counts. Okay? It would be accepted, but I think 2 is the better of the 2 answers. I know one person that got them all right. How about most of everybody else? Did we do okay? Made 1 or 2 mistakes, maybe? Here's what I will guarantee you, which is kind of nice. If you happen to make a mistake, ooh, it's back, fun. If you happen to make a mistake with that, okay, I'm not automatically going to mark you wrong in the next 2 columns. I will look at what answer you provided and then base what these 2 answers should be based on what you said. Does that make sense? So you don't get double jeopardized, okay? So it's going to take me a little while to grade them, but that'll be okay. I want to give you as many points as I can. Because if you, based on what you gave, can you correctly tell me the test statistic and degree of freedom? That's fair enough, okay? So what I'd like to do is I'd like to take some time and practice. So I'm going to divide you up into teams. And I have a website that we're going to go to, and we're going to play a game. And the link to the website's on School Fusion. I'm dividing you into teams. And you're going to, so you want to kind of close up your stuff on your desk, so because you're going to move around. You don't have to take your stuff with you, because you will come back to your desk. But I'm going to divide you up. So here's what you're playing for. You're playing for extra credit on your test. Okay? So I'm going to keep score. Shh. The link to this that I'm getting ready to show you is on School Fusion. And it brings up this particular screen. Let me make it bigger so we can read it. I learned how to do this during block 1. Hang on. All right, so it's bigger. So in this scenario, all of these are what you want to select because you shouldn't have to do all of them except for the very last one. We did not do a NOVA test. It is a statistical test. It's not in the AP Stats curriculum, so we're not going to do it, okay? So you're going to pick these. When you click on that, you're going to click Submit. What's going to happen is I'm going to start with a group. I'll do eeny, meeny, miny, moe, figure out which group I'm going to start with. You get 2 points if you answer it correctly the first time. If you don't, the other group gets a chance to steal for a point, and then we'll go back and forth that way. We'll play for about 20 minutes, see how far we can get. I'm going to pause the recording because this doesn't need to be part of the recording. You can do this on your own, okay? Where am I? I'm going to sit back here only because it pops up as a back window. Try to find it there. All right, so I just handed this out to everyone. This is the second, by the way, these 2 questions on this sheet, you will have questions almost identical to them on your test. So the 2 handouts I've given you today, you need to study them, okay, period. Very similar to what's going to be on your test. Different numbers, obviously, but same format. If you look at question 2B, you'll see that this question 2 deals with a chi-squared test. We know it's chi-squared because it actually says the word chi-squared, and we're actually given your observed, but these are all your expected values. And they gave them to you, but in question 2B, it asks you to show the calculation for how you did that. Now, when we did this before, I said to take your row total and divide it by the number of categories, if you remember. But that was only if the number in each row, or each column, sorry, was the same. If you notice here, they're not. Would you agree? So you actually have to have the same proportion. So to do question B, it's a little bit different than the example we did in class. You are wondering how many out of 382 does go here. That's what I am looking at that question. I'm looking at my row total. How many of 382? But it should be the same proportion as 222 out of 800. So you're going to actually write a proportion to solve this problem. Does that make sense? When we did it in class before, these column totals were all the same, so we didn't have to do that. But now they're not. So I just wanted to make sure I pointed that out to you, okay, because that's a little bit different. If you also look on the bottom, I don't have it on the smartboard, but question 3, the computer printout is small. Remember that. You're not given your test statistic. You're not given your p-value. I warned you about that when we went over the homework. You need to be able to show me how do you find the test statistic, how do you find the p-value. Yes, ma'am. Yes. Yes, which is why I just went over it. I wouldn't have gone over it if it wasn't going to be on there. Okay, definitely. Like I said, the format of the test is very similar to what I just handed you. In addition to the sheet where you have to make all the decisions about which test to use, these 2 problems, you will also have to perform 2 chi-squared tests from the beginning, fully, and 1 LinRegT test with a computer printout. Fair enough? So in addition to what you have, you're going to have to practice this. I'm going to give you back your chi-squared quizzes today so you can look at what you missed and what you did well. I think I already texted you the problems from the textbook that you need to do. So they're on School Fusion as well. They are from the review of this chapter. So what I'm looking at here is what's due on Tuesday. Well, you don't have to do the 2 sheets because the one we did in class. But the sheet I just handed you, questions 2 and 3, and then I think there were 4 textbook problems, correct? I think that was it. That's your review for the test. You should use the website to practice which test to use. The link, again, is on our School Fusion homepage, okay? All right, let me hand back your quizzes.